know what are the integer solutions to this equation. So what are all the integers x and y so this equation is satisfied, if there are any? How do we go about solving this? Now, rather than just tell you the solution, I'm going to take you on a journey of discovery to show you the principles. So here what we can do is the first step, if you're really stuck, is just to tabulate some values. Okay, and the answer is going to turn out to be super easy in the end, which is really fun. And I'm going to ask you some questions while we do this, but let's just tabulate some values of x and see what we get. Okay, so I'm going to go values of x all the way up to x is equal to 6 or 7. Okay, so let's just go up to 7. Now, each case we want to figure out what is x squared plus x plus 1, and then we want to do the same thing for y cubed minus y and get some pattern. Maybe understand what's going on. So 0 squared plus 0 plus 1 is 1. 1 squared plus 1 is 3. 2 squared plus 2 plus 1 is going to be 7. 3 squared plus 3 plus 1 is going to be 13. 4 squared plus 4 plus 1 is going to be 21. 5 squared plus 5 plus 1 is going to be 31. 6 squared plus 6 plus 1 is going to be 43, and 7 squared plus 7 plus 1 is going to be 49 plus 7, which is 57, plus 1 I meant, which is 57. So we're getting those values of x squared plus x plus 1. Let's head on over to the y cubed minus y and see what we get there. So y cubed minus y, we can again tabulate some values, and as you will see, they grow a whole lot faster. Okay, so I'm just going to do a few values all the way up to 4, and that will already kind of get to really big numbers. So here we've got y cubed minus y. Well, 0 cubed minus 0 is 0. 1 cubed minus 1 is 0. 2 cubed minus 2 is 8 minus 2, which is 6. 3 cubed minus 3 is 27 minus 3, which is 24. And 4 cubed minus 4 is going to be 60. So we're getting these values. And already you see there are some near misses, right? I mean, you sort of want to say, okay, we don't find any solutions so far, but there are near misses because 6 is very close to 7. Right? 6 is very close to 7. 24 is pretty close to 21. Okay, it could have been hit. There could have been a hit there. 60 is pretty close to 57. So it's not quite the same though. So it looks like there are no solutions, but you can't just say that right now. You can't just say there are no solutions because we tried out some numbers. We have to show that no number is satisfied if we are going to say there are no solutions, and that requires a mathematical proof. And so my question to you, I want you to drop a comment down below. What patterns do you see? Okay, so if there are no solutions, there should be some pattern here and some pattern here that allows us to say this can never equal this. Do you see some pattern? And it's a very simple question actually. There's a very simple pattern that these numbers satisfy, that these don't. And I want you to drop a comment down below what it is. And assuming you've done so, pause the video. Let's get into it. The trick is, and this is just an observation, this always looks like an even number. This always looks like an odd number. That's all there is to it. And actually we can prove rigorously this is the case. And let's look at what that looks like. So x squared plus x plus 1. Now I'm just going to write this in words, and you can make a mathematical proof out of it, but I want to keep things intuitive for now. Even squared plus even plus 1. What happens when you take an even number x? What is the parity of x squared plus x plus 1? Is it even or odd? Well, an even squared is always even. Two even numbers added up is always even. Add 1 to that, it becomes odd. So x squared plus x plus 1 is odd when x is even. What about when x is odd? What is odd squared plus odd plus 1? Well, that's going to be an odd number squared is odd. You can just play around with it. 3 squared or 5 squared to get a feeling for it. Those are odd numbers. And then odd plus odd is even, plus 1 is odd. So x squared plus x plus 1 is always odd. Okay, this is always odd. On the other hand, y cubed minus y, what's going to happen there? Well, y cubed minus y, again, you can sort of try the parity, okay? It may depend on whether y is even or odd. So let's try even cubed minus even. Well, again, even numbers, you multiply them together, they're always going to be even. So even cubed minus even is actually going to just be even. It's a difference between two even numbers. And odd cubed minus odd, well, what's going on there? Odd cubed minus odd, well, it's a difference of two odd numbers. The cube of an odd number is always odd. Okay, so you can just again play around with that. 3 cubed is 27, for example. You can prove this rigorously too. I'm not going to do it in this video, but drop a comment down below what the rigorous proof would look like for you. Okay, that also would be interesting to me. There are many ways of looking at it. Odd cubed minus odd is a difference of two odd numbers, which is even. And now we see that therefore y cubed minus y is always even. And because one number is always even and the other number is always odd, there cannot be an equation. And so therefore these numbers never match. They could get very close. We don't know. We haven't ruled out that at some point they could be 1 apart. I mean, already they're 1 apart for 6 and 7. Are they 1 apart for any other numbers? Drop a comment down below if you think that there are 1 apart, or not? What do you think? Drop a comment down below. How close can they get, as x and y get larger? But that's the proof that this equation is never satisfied for integers. Thank you so much for watching. I'm super excited to see you in the next video. Remember, my channel has math content at all levels across all topics. I'm not specializing to one kind of math. I'm doing high school math, college math, proof-based math, math problems like this. I'm a research mathematician. I received a university-wide faculty teaching award at Princeton. I understand how to communicate math, and I love doing so on my channel, and I'd love to have you join my channel, be a part of my vision to change lives through math education, delivering infinite accessible free education worldwide. Thank you so much. I wish you all the best, and I'll catch you in the next video.